It's the side-splitting theorem. Side-splitting theorem says a line parallel to one side of a triangle divides the other two sides proportionally. Okay, here is a line DE which is parallel to BC. So it's parallel to the bottom of the triangle there. And so what we're saying is that with this rule is that AD over DB equals AE over EC. Now, because of that, notice that we have two congruent angles here. Angle B, let me make that darker here. Angle B is congruent to angle 1. Angle C is congruent to angle 2. So what we have here is we have two similar triangles. Triangle ABC is similar to triangle ADE by the angle similarity postulate. So we have two similar triangles. And so what that means is then that AD is to AB the same as AE is to AC. Okay? In other words, the AD, that's this one, is to AB the way AE is to AC. And I know it's hard to see, but what we have is we have two similar triangles. The first one looks like this, and the second one looks right over top of it, looks like this. Okay? And it actually is kind of like the letter A, isn't it? Except for that bottom line there. So this is what we mean. We have two similar triangles. Okay? And so we can show that and also this is equal to DE over BC. So any side of the smaller triangle is in ratio, in proportion with the corresponding side of the larger triangle. So what does this all mean? How do we use this in solving problems? Oh, I'm glad you asked that question. How about, well, wait, wrong one. We'll get that later. Here we are. Okay. So we have a missing angle, or a missing side here, don't we? Missing length. We want to know what x is. You know what they say, find x? I found it. It's right here. Okay, that's a little joke, but that's okay. We're all done with that. So, anyway, so I have 12. I have 12 over 16 equals 15 over x. And so obviously you just cross multiply. 15 times 16 is 240. That equals 12x, because you cross multiply the other way too. And so 12x. So divide both sides by 12 and you get x equals 20. And so that's how you do something like this to find a missing side. And there's one more thing, and that's the two transversal corollary. And so now we can look at that other thing I was showing you a minute ago. There we go. All right, the two transversal corollary. These two red lines are what we call transversals. Okay, so L, M, and N are all parallel. Okay, so the transversal corollary says 3 or more parallel, that means parallel, lines divide two intersecting transversals into, divide two intersecting transversals proportionally. And what that means is AB over BC equals XY over YZ. And of course, you think about it, it's just like before, we had a triangle, okay? And just like we had two triangles, it's very, very similar. That's why we call it a corollary, very similar to the other thing that we talked about. So anyway, before we go, I have to show you this from the textbook, because this is pretty cool. Every once in a while, you see something like this: Cultural Connection Africa. Students in ancient Egypt studied geometry. Boys and girls, this has been going on in this country for a long, long time. I didn't invent the subject, okay? They studied geometry to solve practical problems involving the pyramids. This problem is based on a problem in a papyrus, copied in 1650 BCE by the scribe Ahmes from a source that may date back to 2000 BCE. And look what we have here. We have the exact same thing, and it's from this brown papyrus over here on the left. And so it's the exact same thing that we're studying now, the two transversal proportionality corollary. So thousands of years ago, Egyptian kids were studying this stuff and trying to solve problems. So, speaking of solving problems, your practice problems are on page 528, and they are 6, 8, 10, and 12. Before you get freaking out on me, those are pretty simple. The important thing is to remember which proportions. Make sure you have the proportions set up correctly, and you have to think about that. And your homework, by the way, is page 528, 14 through 24. Even. Thank you very much. Have a great evening, a day, whatever.